Hello everyone. In order to get familiar with the scope of the subject, in this short video, we will consider a few problems of interest in heat transfer. So the objective of this video, it is to focus on some practical problems in heat transfer and hence to understand importance of the subject. So what practical problems in industries we are going to focus on, which are related with heat transfer. So the first problem that we will consider, it is related with heat transfer through thermal insulation on a pipe. So here you can see a piping system, number of pipes present here, and these pipes are surrounded by a insulation. So insulations are provided onto this pipe. The reason is through this piping system, a fluid with high temperature or hot fluid it is flowing, and if we are not providing insulations, what will happen is as inside temperature is high as compared to the surrounding temperature, there will be a transfer of heat from inside to outside. So this heat loss have to be avoided, and hence there is a need of providing some material which will restrict the heat flow, and this material which restricts the heat flow we call it as insulation. So here in the first problem, when we are talking about heat transfer through thermal insulation provided on a pipe, we can say that it is primarily a problem of conduction heat transfer, because it is a heat transfer that is occurring through a solid body, or we can say that it is a heat and heat interaction between the two solid bodies which are in contact, which is nothing but a pipe and the thermal insulation. The second problem that we'll deal with, it is related with steam condensers which are used in thermal power plants. So in thermal power plants, once the steam comes out from the steam turbine, so the steam will have a very low pressure and some higher temperature, and this steam needs to be condensed again, and this condensed steam will be fed back to the boiler for again for generating the steam again, and this process of condensation, it is done in this particular part or in this particular equipment which is known as a steam condenser. So here what basically we are doing is the water will pass through number of tubes which is having a low temperature. So the steam will get condensed on the outer surface of the tube by transferring its heat to the cold water, and hence the cold water temperature will increase. So here basically it is having primarily having a mode of convection heat transfer. So this problem specifically deals with convection heat transfer mode. Then we'll discuss about a heat treatment process in which you can see here the components are red hot. It means that they are having reached to a very high temperature, and then this high temperature objects are taken out to cool it atmospherically, and this is nothing but a kind of annealing process or any other heat treatment process you can consider. So here basically you can see there we have a furnace. So the heat treatment of these objects and heating of these objects, it is done primarily by the mode of radiation. If we have electric heaters mounted onto the top of this furnace, so they will radiate the heat, and this heat will be absorbed by these objects and they will get heated up. So primarily this problem will be related with the radiation heat transfer. So now we'll focus individually on each and every problem that I just discussed about. So the first problem is related with heat transfer through thermal insulation on a pipe, and specifically here we are talking about a steam pipe. Because in most of the industries, steam is required at different locations for different types of purposes, and hence there is a need of transportation of steam from certain generation point to the different points of use. So let us consider that there is one point of generation at which the steam is generated, and then this steam, it is transported through a piping system to the different points of use. Here I have shown just one piping system, but there can be a number of piping systems you can have. So if I want to transport the steam from point of generation to multiple points of use, what I will do is I will make use of a piping system arrangement in which the pipes will be either in parallel, or there will be a branched kind of piping system I can have. So here the problem is when the steam is being transported from point of generation to the point of use, if I'm not providing any insulation around it, what will happen is as the steam here you can see it is at a high temperature of which is having around 170 degrees Celsius. So inside we have a very high temperature, and outside we have a surrounding temperature which is very low as compared to this. So because of this larger temperature difference, there will be a transfer of heat from inside to the outside, which is shown by these red arrows. So this is nothing but a section of this pipe I am considering. So this is a cross section of the same piping system that I have shown here. So the first system is nothing but a steam pipe without insulation, and here what will happen is there will be a easiness and quickness of transferring the heat from inside to the outside, because these piping systems, they are made up of metals or metallic materials we can have, and metals we know they have a good capability of transferring the heat. So through this thickness, heat will get quickly transferred, and because of which the heat loss from this system to the surrounding will be very high. And how to avoid this problem then? So what we can do is, around this pipe we can provide some insulation. So insulation is nothing but a material which restricts the heat flow, and because of which what will happen is, even though inside and outside temperature difference is very high, because of restriction present during this thickness or around this thickness, the transfer of heat from inside to outside will be decreased. So here in this particular case, in which there is a steam pipe with insulation, there will be a reduction in the heat loss rate. And specifically we are interested in calculating the heat loss rate per unit length. The reason is, if I know in unit length how much is the heat lost from this system to the surrounding, I can calculate that over the entire length of this piping system how much amount of heat will get lost. So I can identify, with the use of this particular heat loss rate per unit length, what will be the temperature of the steam which is coming to the point of use. And now we will focus on the analysis of this. So let us consider, we have plotted one graph. So on x-axis we have thickness of insulation in centimeter, and on y-axis we have heat loss rate in watts per meter. So this is a heat loss rate in watt per meter. It means that it is per unit length heat loss rate I am talking about. So here one cross mark you can see, which is a cross mark which shows that here we have zero thickness of insulation. It means that when I'm not providing this thickness of insulation, I'm not providing any insulation, the heat loss rate will be very high, which is shown by this cross mark. And then what will happen is, as I continuously increase the thickness of this insulation, the heat loss rate will continuously go on decreasing. So it is a generalized way in which the heat loss rate will reduce, and this is a kind of behavior shown by this curve, which is nothing but, with increase in thickness of insulation, the heat loss rate will continuously go on decreasing. Now here, if we consider that this is nothing but a kind of problem which is posed towards a heat transfer engineer, and he might be asked to solve this problem in different number of ways. So the first way we'll consider, like the heat transfer engineer, it is being posed with a problem like, he is asked to calculate how much will be the heat loss rate for some particular thickness of insulation. So let us say that I have provided 3 centimeter thickness of insulation, and with this 3 centimeter thickness of insulation, how much will be the heat loss rate from system to the surrounding have to be calculated. So what he will do is, so he will mark this particular thickness of insulation, let us say 3 centimeter. From this point we can draw one vertical, and this vertical will intersect the curve somewhere here. From this point we can plot one horizontal, and it will intersect at this particular point. So here we can say that with this particular 3 centimeter thickness of insulation, we will get this particular amount of heat loss rate in watts per meter. So we can identify here that without insulation we have a very high heat loss rate, and with insulation this heat loss rate has reduced to some very significant value. So this is a one kind of problem. The second kind of problem is, it might be controlling of heat transfer rate. So heat transfer engineer might be asked to allow the heat transfer rate of some value. So let us say he has told that he's being told by his authorities that you have to maintain the heat transfer rate to some particular value, which is shown by this cross mark. And for this particular heat transfer rate to be allowed, how much thickness of insulation need to be provided. So he will make a cross mark here, and from this point we can he can draw one horizontal which will intersect this curve here. From this point one vertical can be plotted, and this point it will give the thickness of insulation for which this particular rate of heat transfer can be given. So this is a first kind of problem which is related with conduction. Now we'll talk about heat transfer to water flowing through a tube, and I told earlier that this is a kind of system which is known as a steam condenser. So in internal part of the steam condenser it is shown here. So you can see here that there are number of tubes which are in a bunches. So what I'm doing is I'm considering a very single tube for analysis purpose. So let us say there is a one tube I'm considering from a bundle of tubes of steam condenser. Into this tube water is entering at 30 degrees Celsius, and outside of this tube the steam we have which is coming from the steam turbine, which is having a low pressure and let us say temperature of 50 degrees Celsius. So as inside temperature is less as compared to outside temperature, the heat transfer will be there from this steam at 50 degrees Celsius to the water at 30 degrees Celsius, and this steam will get condensed on the outer surfaces of the tube. So here the question is, when the water is entering at certain temperature, let us say 30 degrees Celsius, and it is traveling a length of 2 meter, and when it exits this system, what will be the temperature of water? So this is the first kind of problem that can be posed towards the heat transfer engineer. So it means that water is entering at 30 degrees Celsius and leaving the system. So while leaving, what temperature it will attain? And it is nothing but a temperature attained for some specific length of 2 meter we can consider. So it is a first kind of problem that we can say. Second kind of problem is the water is entering and it is leaving the tube, and let us say we want to control this temperature. So let us say we want to have outlet temperature of 40 degrees Celsius. So to have entry temperature of 30 and outlet temperature of 40, what should be the length of this tube? What should be the length of this bundle of tubes that I am talking about? So these are the two different ways of seeing the same kind of problem. So here there is a heat transfer from liquid or gas to the solid, and this is the primarily problem of convection heat transfer. The third problem that we'll focus on, it is heat transfer in an electric furnace. So as I earlier told, it is a heat treatment process that I'm talking about, and it is primarily a problem of heat transfer due to radiation. So let us say there is a rolling operation being done on a steel strip. So what exactly happens is, so initially it is having some larger thickness, and once it passes through the rolls its thickness will get reduced. So it is a kind of deformation that is being done to reduce the thickness of the strip to some lower value, and because of this reduction in thickness, the mechanical properties like ductility, malleability, and all other different properties may get changed, and we want to restore these particular properties. So there is one heat treatment process which is known as annealing, which can restore these mechanical properties. So let us say we want to do the annealing process, and in annealing process what basically we are doing is we are heating the material to say around 600 to 700 degrees Celsius, and then we are cooling that material with atmospheric cooling. Means with atmospheric air we are cooling the material which is at a temperature of 700. So here what we are having is the strip which came from rolling operation, so it will enter into the furnace. So let us say there is some length of furnace we have, and there are electric heaters provided, so which they will give heat energy to this particular system. So the heat transfer from this electric heaters to the steel strip, it is by radiation. So when the strip will enter and it will travel this particular distance, when it will leave, it should attain the temperature of 700 degrees Celsius, which is the specified requirement. And for this there can be again two different ways we can have. So let us say the length of the furnace is fixed, and I want the exit temperature of this strip to be 700 degrees Celsius. So in order to maintain this 700 degrees Celsius of exit temperature, I need to maintain its velocity. So the first problem is what should be the velocity with which the strip should move, so that after traveling this particular length of the furnace, the strip will achieve 700 degrees Celsius of temperature. Or the second kind of problem is the velocity is fixed and I want 700 degrees Celsius of exit temperature. What length of the furnace to be given? So this is nothing but a kind of problem which is related with radiation, and this is all about the different interesting problems in industries that may be faced by the heat transfer engineers. Thank you very much for watching this. Have a good day.